We are entering the nano age, and small is big. But to make big things happen in small dimensions, scientists had to understand the molecular world in new ways. For one insightful chemist, understanding that world was only the beginning. Thanks to George Whitesides, we not only understand, but can build worlds, one molecule at a time. George Whitesides was born in 1939 in Louisville, Kentucky. He was exposed to chemistry early on from his father, who was a chemical engineer.
His company made glop plastic that you put on the insides of silos to keep the silage juices from dissolving the concrete. And so I got to spend the early teenage years taking plastic and putting it on concrete and dripping acetic acid over it. And what I found was I liked making very simple measurements.
He studied chemistry at Harvard and at Caltech for graduate school. Then he joined the faculty at MIT, where he stayed for almost 20 years. It was during this time that he realized he was as much a businessman as a scientist.
At MIT, when you come up with something new, people ask you, what's it good for? And at Harvard, people ask you, why is it interesting? And I like both, and each works well in its own way.
George and I, when we look at starting companies together, it's really more of a function of daring to come up with a new invention that can make a big difference to mankind. Any intersection between chemistry and material science and a product that could be a big deal, we think that's a great opportunity.
But Whitesides never stopped being a chemist. In 1982, he returned to his alma mater, where in a few years he became chair of the chemistry department. An exciting new field soon caught Whitesides' attention. Its goal was to control structure at the level of individual atoms.
My interest in nanotechnology, as it's now called, is a perfectly natural extension of chemistry, because of course molecules are nanometer scale objects.
But how would such tiny, precise structures ever be made? People or robots certainly couldn't build them. So Whitesides began thinking about living systems.
Most of the world is self-assembly. We are self-assembled systems because no one puts our molecules in place. The molecules put themselves in place. How would one build a computer or a simple device that assembled itself?
This insight would give rise to the revolutionary new field of self-assembly. Whitesides was the first to use this tool in nanofabrication, creating with his Harvard team amazing structures.
What I photograph of George's work are visualizable. He's a tinkerer. He puts things together. And the beauty of this stuff is that sometimes you can't even imagine why he decided to put it together. And that's where the creativity is.
They designed organic structures called monolayers, films exactly one molecule thick that assemble themselves onto surfaces and then change the properties of those surfaces. These systems have allowed researchers to manipulate living cells and develop disease-fighting drugs. And for Whitesides, that's just the beginning.
You can imagine building electronic devices out of organic molecules. And it's beginning to work. A very interesting potential application is in areas like lighting. They have a green component, and some of them are turning out to be astonishingly good.
This research could even help improve worldwide health care.
The idea of zero-cost diagnostics is to find ways of making diagnostic systems, particularly for the developing world, that effectively cost nothing.
Whitesides also serves on a number of high-level advisory bodies, like the Committee on Science and Technology for Countering Terrorism.
In the long run, we solve problems, create jobs, help the world be a better place or a safer place, or contribute to national security. So there's a real reason for doing it.
When you look at all three areas, science and technology, impact on business and products, and impact on governments, it's hard to find anybody in the last 50 years who's done what George has done.
And just because he works in the realm of the super small, that doesn't mean he's lost sight of the big picture.
One of the futures for science, and for chemistry, of course, is to understand how you go from these processes that transform molecules into one another, from that to Beethoven. How does that work? And it's remarkable that we don't understand how that happens, but it is chemistry.
The 2009 Benjamin Franklin Medal in Chemistry is presented to George Whitesides for his pioneering chemical research in the field of molecular self-assembly and his invention of rapid innovative techniques for the inexpensive fabrication of ultra-small devices for practical use.